Welcome to Unit 3, Triangles. And our first part of the unit, our first lesson is going to be on the exterior angles theorem. And so, quick review of the parts of a triangle. Then we're going to talk through the exterior angles and the remote interior angles of the triangle. So, let's get started here. Triangle, let's do some shapes here. We can do a triangle. Oops, let's do it this way. There we go. And I'm going to select that and move it actually. There we go, look at me go. All right, so here's a triangle. Let's talk about the parts. All right, so first of all, we have angles. Right, angles are here, here, and here, just like so. Okay, there are three of them, hence the name triangles, right? All right, so I'm going to scoot in a little bit so you can see better. All right, so then we have something called, I'm going to change colors here. We'll go red. Let's see how big it is. All right, we're going to go sides, and the sides are here, and here, and here. Okay, those are sides. Now, the bottom side has a special name, so this is called the base. And then there's one other piece that you're going to need to know later. I'll do it in fancy color here, and it is called the altitude. And that is really how high, right? Because we know altitude, like planes, we talk about that. Altitude is how high. So if I do a line here, straight down, this is your altitude right there. Now, one thing to point out about the altitude is this. So if I'm going to draw a funky triangle here. I mean, it's not that funky, but it's going to look a little different than this one. And I'm going to take one more line and draw it right here. All right, so if I have a triangle like this, now our altitude is a little bit different because, oops, look at that, undo. I don't want that line to be, oh goodness. All right, we'll stick with this, hold on. We can do this. All right, so if I go straight down like that, now I can make that one fun. All right, so this is the altitude. Sometimes it winds up outside because if you just continue this line, you would have it out this way. So we'll talk more about altitudes later, but just FYI. So these are the parts that you're going to need to know for what we are working on today. All right, so let's talk about exterior angles. All right, so all these theorems and postulates and things, most of them come from, our guy Euclid, who was kind of he was the old guy from Greece who made a lot of these discoveries about the math behind geometry. So he's kind of the father of geometry, and so this is one of them. And so if we take a line here and make the base of this one stick out further, so like so. Now we have some interesting things. So we have an angle here, right, on the outside, and this is called an exterior angle. Now I will say, totally a side note here, over here in the red, is sometimes you'll see a triangle like this, and it will have two lines. So if I start a line and go this direction, I see this all the time when I'm helping my students in the BLP with their geometry. Okay, this right here, this angle, that is a vertical angle. Remember from our Unit 1 where we talked about transversals and all those things? This is a vertical angle. because it is congruent to this angle right here that I labeled as x. Okay, So don't get those confused. That's not an exterior angle. Exterior angles are going to be these one here. This one's an exterior and this one's an exterior. Okay, they're the ones that are adjacent to what we are doing. Do I not have my, look at that. Okay. They're adjacent to what are along the same line. So they make a linear pair. If I highlight this along this line, this one and this one are linear pairs. So they make a line there. All right, so going back to our original example, this one's an exterior one. These all in here, these are interior angles. And this one over here, X is a remote, or sorry, is an adjacent interior angle. So these two are remote interior. That one and that one. All right, so now if I label these, I'll label this one A, this one B, and this one C. Now there's some interesting things because remember, something that's important is that the sum of the interior angles of a triangle is 180 degrees. Also of note, linear pair angles add up to 180 degrees. All right, so this is really important to note. So over here, if we look here, we've got the interior angles. We've got A plus B plus X equals 180 degrees, right? So on this line down here, we can see that X and C make a linear pair. So we'll do C plus X is equal to 180 degrees. So now, if we look at these things, these groupings are the same, right? A and B has to equal C, right? Because if we have A plus B plus a number makes 180, or C plus the same number equals 180, then those two things, A and B, have to equal C. So let's take a look at that in some problems and see how that really works out. All right, so now the letters have changed. They're not A, B, and C necessarily, but this is a remote exterior angle that we're trying to find right here. Or sorry, not a remote exterior, just an exterior angle. And we're trying to find that one. So we'll call this one, we'll call it X. So X is going to be equal to either this one here, but we don't know that one, plus or subtracted from 180, or it's going to be just equal to these two added together. So if we add 20 plus 66, that makes 86. So X would equal 86 degrees. So we think this makes 86 degrees. Well, let's test this out. All right. So if our missing one here, let's call this one A. If A plus 20 plus 66, all of the interior angles, they must equal 180 degrees. So A plus 60 or 86, which is a familiar number, equals 180 degrees. Subtract 86 from both sides, and you would get A equals 94. Now, comparatively, so now I have 94 right here. So this is 94. So 94 and X, so 94 plus X has to equal 180 degrees, right? Well, subtract 94 because this is a linear pair. They're supplementary angles. So I subtract 94 from each side, and guess what I get? 86 degrees. Okay, so no matter how you solve this, it works out the same way. So you could find the missing angle and then use the supplementary angles to do it. Or you can simply just say this, that x is equal to the sum of the two remote interior angles. All right, so let's try it on this other example. Now this time, this is the exterior angle. So exterior angle equals, so the exterior angle is equal to the remote, we'll just say the sum of remote interior angles. So in this case, the exterior angle is 80. The remote interior angles are these two, right? They're the remote ones inside, so they're not the one next to it, but the other ones, equals to 46 plus v, right? So we want to get v by itself, so we're going to subtract 46 from each side. And then this one, if you want to do the math properly, you can borrow here. 10 minus 6 is 4. 7 minus 4 is 3. That crosses itself out. So v is equal to 34 degrees. Okay, so what you always want to do is set up an equation where the remote exterior angle is equal to the sum of the two, so set up an equation where the exterior angle is equal to the sum of the remote interior angles, and then you just have to solve for which one is missing. All right, that is your lesson for today, and good luck on your practice.